Okay, we are getting started now. Welcome to this weird, wet Wednesday. We only have 3 weeks left of class, minus a day because of Memorial Day. So we really need to rock it to get through this stuff. Should be at least 2 more homework assignments plus your final, or 1 more assignment plus your homework final, maybe 2. Things we still have to get through are Polymorphism and Inheritance, which hopefully we'll knock out today. Smart pointers, which we'll also get through today. And then exceptions, which are really easy, and then C. And then we're done, hopefully. We still have some other things to review, like Google Test, and hopefully we'll have time to squeeze in how to talk about another library. People haven't been coming to office hours after class. Maybe you guys are just good and you're being very productive and you're getting your work done, but don't let those late deadlines fool you into not working. You really should be focused on getting the things in on the due date specified if you want to be able to finish on time, because there's still going to be a lot of work left to do in this class and a very, very small amount of time to do it. And so we're really going to rock it now. So last time we talked about unique pointers. We covered some of their operations: reset to delete whatever you're pointing to and assume ownership over another pointer, release to give up ownership of a pointer, and swap if you want to exchange the contents of what these 2 pointers point to. Sometimes, though, you might need access to that underlying dumb pointer. The most common reason that you would need that would be to pass it to a function that requires a pointer as opposed to a unique pointer or some smart pointer. For example, you might be making a call into a C library where they only have normal pointers. So you would need that base pointer. The way that you do that is .get, and .get will give you the underlying pointer. Just make sure that whoever you give this pointer to is not going to delete the thing, because again, it's still your responsibility to delete that. So over here we have a swap function that just takes in basic integer pointers. So here, though, I have some unique pointers to an integer, but I still want to be able to swap. Again, we probably should just use the swap method, but here what we could do is we could use the .get to pass in the underlying pointers, so this function could exchange the values. Any questions on get? Yeah?
How does it
So if a function was going to accept a smart pointer, we'll see it over here on the next slide. So one thing about functions and smart pointers, say unique pointers, is unique pointers, they have to be unique. They should be the only one owning it. That means you can't create copies of a unique pointer, because then how many people would be owning it? More than one, right? And so it would no longer be a unique pointer. So if you want to be able to pass your unique pointer to a function, instead you're going to have to pass a reference to that unique pointer, because again, that will cause you to not create a copy. Though in general, if you just wanted access to the value, it's much better to pass a reference to the value as opposed to passing the entire smart pointer. Because people don't need to mess with the smart pointer, they can just mess with the value if they need to be able to modify it. So over here is a function, right, that prints out the value, and so we accept a const std unique pointer to an int reference, and then I can dereference that pointer. But again, it would still probably be better to call this function over here with a const reference to an integer, and then you could just dereference your unique pointer when you called it, because this function has no need to access any of the unique pointer's components. It just needs the value that it points to. Does that make sense? Any questions here? So even though you cannot copy a unique pointer, you can move a unique pointer from one unique pointer to another. When you do this move, it transfers ownership from the right-hand side to the left-hand side. If the left-hand side was currently pointing to anything, it deletes it, and then it assumes ownership of whatever was on the right-hand side. The right-hand side will then have null pointer. So the way that you specify a move is by using std move. So here I'm moving my unique pointer into other. So now other now assumes ownership over this value 5, and then we're going to make ourselves unique pointer would point to null pointer because he doesn't own anything anymore. So it is possible to move values around. Any questions about move? I do recommend that you look up on your own time move and right-hand side references. They're a really interesting concept. I just don't think we're going to have time to cover them in this class. One other thing is that if you have a unique pointer as part of your class, since unique pointers aren't copyable, it means your class is no longer by default copyable. Because to copy an instance of your class, you would have to copy the unique pointer, and unique pointers are not copyable. You can still totally define a copy constructor though, but now you're going to have to define what it does it mean to copy this unique pointer. Generally what you're probably going to do is create a new instance of that object, right, and make your new unique pointer point to that object. But you can make whatever you can do whatever you want in the copy constructor as long as it makes sense for that object. So shared pointers are for when you have a single resource that multiple objects share, and only after all of those objects should be deleted, or after all those objects are deleted, should that resource be deleted. For example, you might have a pointer to the database, and everybody needs to access this database, and you only want that one resource to be created, but multiple people to be able to access it, and only after everybody's done accessing it should you destroy the database and close it down. An example from real life to kind of relate to this is like you guys have a lease, you probably have roommates, right? You and your roommates share this lease. You should only destroy your lease after everybody moves out of the apartment. So shared pointers, they have all the exact same methods that unique pointers have, except if you want to make a shared pointer, use make shared as opposed to make unique, and there's no .release method on a shared pointer, because again, everybody's sharing that object. You can totally make copies of a shared pointer. When you make copies of a shared pointer, now one more person is asserting ownership over that object. When you use the .reset method, that shared pointer, the data that the shared pointer deletes to is only going to be deleted if it's the very final one that was pointing to it. So over here, I make a shared pointer called sp1 using make shared, and I make some other shared pointers sp2 and sp3, and they're all also going to be equal to sp1. So now 1, 2, and 3 are all asserting ownership over this single object 5. And only after all of them are deleted would the 5 be deleted. So if I do sp1.reset, that 5 is not deleted because sp2 and sp3 are still asserting ownership over it. But sp1 no longer points to that object anymore, no longer points to the 5. So if I print out sp2, you'd see 5. If I do star sp3 equals 12, it's going to turn that 5 into a 12. And sp2 would also see that this change has happened as well, because they're pointing to that same object. If we do sp2.reset, sp2 gives up ownership, but still not deleted until finally sp3 gives up ownership. Now nobody owns this object, and so it gets deleted. Any questions here? Yeah. So this is not saying sp3 points to 12. It says change whatever sp3 points to 12, right? So it goes and it changes this guy over here, this 5, to a 12, right? But it's not making it point to something different. But if you did make sp2 point to something else, then it would stop asserting ownership over that value. And so the use counter would go down by 1. So it wouldn't be sharing anymore because it's now asserting ownership over somebody else instead. Yeah. Reset does not return anything. Void. Anything else? Okay. So the way that shared pointers work is they use a reference count. So they keep track of how many people are referring to this object. Every time you make a copy of a shared pointer, the reference count goes up. Every time a shared pointer gets destroyed or calls reset or points to something different, that counter goes down. Once that counter finally hits 0, then we delete the data. You can get the current number of elements that are referring to a shared object by doing that shared pointer.useCount. It'll tell you how many people are referring to it. So if I make, again, this value 7, and I ask for its use count, only sp1 points to it, so use count would be 1. If sp2 and sp3 now point to sp1, right, the use count has now gone up to 3. 3 objects are pointing to the same set of data. If sp1 resets, the use count goes down to 2. If sp3 resets, the use count goes down to 1. sp2 resets, the use count gets to 0, and then we delete the object. Does this make sense how it's implemented? Okay, so one thing that you really need to avoid if you're using shared pointers is you cannot make two objects that have shared pointers both point to each other, because their use count will never be able to hit 0 and they'll never be deleted, and so you'll end up having a memory leak. An example of this would be over here. So over here, I have a person class. And notice that each person has a shared pointer to their sibling, so they can keep track of who they are. Back here in main, what I do is I make two people. I make a person P1 and a person P2, right? P1 sibling is now equal to P2, right? So first thing to keep track of, after we do line 13, what's the use count for Matthew going to be? Just one, right? Not a trick question. There's just one person pointing to it. And then after we do line 14, how many people, or what's the use count of Stephen? Still one, right? Now we do line 16. P1, right? That's Matthew. His sibling is equal to P2. So what's the use count of Stephen going to be now? 2, right? And then when we do line 17, what's the use count of Matthew going to be? Also 2. But now we're running into a problem because they're both referring to each other, right? So again, we print out the use counts right before delete, and then we go to delete the objects. And we're going to see over here in my destructor, right, it's going to say whenever that person is destroyed, right, it's going to say that we destroyed that person. So what we'd hope to see at the end of this program is, you know, at the beginning of the program, right, Matthew created, Stephen created, right, then Matthew created, Stephen, or Matthew deleted, Stephen deleted. Or maybe the opposite order, depending on how the things get destroyed. Oops. Don't want to do that one, or this one. So if we run this program, we can see that both people are created, but neither of them is deleted, because we had this circular reference. So imagine what's going to be happening right now. So when we reach the end of this function, right, P1 and P2 are going to get deleted. Let's say the first thing that we delete is P2, right? So P2 gets deleted, and so what's going to happen to the use count of Stephen? Currently the use count of Stephen is 2, right? So P2 gets deleted. So now how many shared pointers are pointing to Stephen? Just one, right? Because we delete P2, right? Matthew is still pointing to Stephen. So the use count goes down to 1, right? We then go, and so because our use count is now down to 1, we won't end up deleting the Matthew because he's still at 2. So then we delete the Matthew, his use count goes down to 1, right, as well. So now we have 2 1s, and neither of them is going to be deleted. Because when we reach the end of the function, they're still referring to each other. And until one of them gets deleted, we can't delete the other. That's a big problem.
Unless I'm thinking, unless you do reference where they're pointing for, I mean, unless you, well, if they're still pointing there, they cannot be deleted, and that memory will always be allocated.
Say it again.
Say we never, count never goes to. Okay. That memory will never be allocated.
Correct.
Even if the program stops.
Correct.
More or less act like normal.
No, they don't. Because again, like this problem right here is because we have this circular reference, right? This is not supposed to be what happens. If this circular reference wasn't here, right, we'd only have a use count of 1 for both of them, right? P1 and P2 get destroyed. The use count goes down to 0, and then the elements would be deallocated as well. Right? This is just showing you a problem of using the shared pointers. It's something to watch out for. Yeah. Depending on the operating system, you might have to. So with shared pointers, right, as long as somebody is pointing to it, right, its use count is greater than 0, it cannot be deleted, right? With like the dumb pointers, right, it's your responsibility to delete the thing at the end of the day. So you would delete it. So again, like what happens here, right, here's Matthew's use count, here's Stephen's use count, right? So we go and we destroy P2. So his use count goes down to 1, right? But we're not going to go delete, and then we go to like delete, so we're not going to delete Stephen because his use count is down to 1. Then we go and delete P1, right? His use count drops down to 1. The program finishes, and they're not going to be able to be deleted because we have this problem here. So we want to avoid doing things like this. And we'll show how to fix this problem in 1 second. Yeah. Well, we know that Matthew and Stephen were not deleted, right? Right? Like, let's say I comment out this line right now. No, now they'll be deleted. See, we deleted them? Because there's no circle now? And now we won't delete them. Because of that circle. The use count doesn't reach 0. Yeah?
So first, what happens to
Can't. Turn off the computer. Turn it back on.
Oh.
Right? Sometimes your operating system, it depends on the operating system, might clean up this memory or it might not. So you do want to make sure that all the memory you dynamically allocate is released by the time your program finishes. Yeah? Mm-hmm. So we're going to get to that in 1 second. Like one of the things that's kind of bad here is, remember, like the shared pointers and the unique pointers are used to assert ownership over something, right? So the way this is kind of being described, right, is that a person owns their sibling, right? The person is now in some ways responsible for like destroying their sibling, right? Like when I die, maybe I should go kill my sibling too. That's kind of what it's saying, because I'm asserting ownership, right? If I was the only person owning my sibling, right, when I died, they would die too. So the logic here in terms of the use of a shared pointer for what we're trying to create doesn't make sense. And so it's a bad usage of a shared pointer here. What we should have been using, potentially, there's 2 workarounds for this. The first one is to use a weak pointer. And the whole point of weak pointers is just to break cycles among shared pointers so that you don't end up with this infinite loop. And a weak pointer is used to observe data that's owned by a shared pointer, but you claim no ownership over that data. You are not responsible for deleting them. An example of this might be like, you live with 2 other roommates and they go and they buy a blender, right? And they say, as long as we're here, you're allowed to use our blender. But when we move out, we're going to take our blender with us, right? So you would be, like, your roommates would be shared pointers over the blender, right? Because when they're gone, the blender goes away. And you would be a weak pointer to that blender because you're allowed to use it as long as it's there. Does that make sense? So again, weak pointers, again, they're used because they don't increase the reference count to a shared object. Now, with the weak pointer itself, you cannot directly access the value that's pointed to because it may be deleted or it may not, right? Because you don't own it at all. So what you have to do is you have to get a shared pointer to that object. And the way that you do that is you call lock. And what lock is going to do is it's going to give you back a shared pointer to that data. But if that data has already been deleted, you will instead get back null pointer. So if we wanted to print this weak pointer, right, we lock the weak pointer to get a shared pointer to that data. And then if that pointer is not null, right, we can print it out. Otherwise, that pointer is expired and that data has already been deleted and we can't do anything with it. Yeah?
the first line should
This one up here? Oh, yeah, by a weak pointer. Thanks. If you have the shared pointer, you can directly access it. And that's why we have to call lock to get the shared pointer. Any questions here? So one question you might have is like, well, which smart pointer should I be looking for? So you should probably always default to using unique pointer because most of the things that you're going to be doing, only one person has ownership over that object, and unique pointers represent that idea. Use a shared pointer if multiple people are supposed to own that data, and that thing should only be deleted if they all go away. Use weak pointers to break cycles among shared pointers. Use dumb pointers just to refer to data that you have no responsibility for deleting. So the way that we could have fixed things back here, there's two different options. One, we could have used a weak pointer here instead of the shared pointer, right? Then we wouldn't be asserting any ownership over the object. Or we could have had a dumb pointer here as well. And that would have fixed the issue. Does this make sense? Okay. So I did a couple of things this morning with your vector class. One thing is that I switched it so that it started using smart pointers. And there are also two different branches of this if you download the entire project. So you can switch between like the main branch that uses the dumb pointers and the using unique pointers, which have the unique pointers. So the first thing that I did was we now have a unique pointer to a T array. So if you want to have an array of elements, a unique pointer can point to it. And we just do T bracket here instead of T. So now over here in my constructors, when I go to make my array, I say make unique as opposed to using the new keyword. This used to be like new T bracket num elements. And then again, make unique again. And also again, make unique as opposed to call to new. Right? If you want to see what the original one looked like, you can switch back to master. Boom, we're back. And you can see that we did new T as opposed to make unique T bracket instead. Right, so that's what changed on those lines. One of the other things that we had to change is right here, our destructor, we had to delete the elements if there were any there. We now no longer have to do anything in our destructor because when the unique pointer goes, what it points to also goes, right? So we don't have to worry about remembering to delete the data. The other thing I had to change was insert, or not insert, it was, I did add some new methods. I added an erase method, which would delete an element at a position. I also added an insert method somewhere. Not sure where you went. So here's an erase right here that takes a const iterator, and we use the const iterator's get pause to figure out which one to delete. Over here in the capacity, instead of using new T, what I'm going to use, make unique, right? And then here, instead of having to do this delete, I'm going to do a move instead. Oh yeah, that. Then here's an iterator or an insert version that uses the const iterator. Just uses the get value. If we switch back to the using unique pointers, you can see I don't have to do anything in the destructor. When the pointer goes, the values are deleted. Accessing the elements is identical to what we were doing before. Insert doesn't do anything new, but when we resize, I have a unique pointer now for temp as opposed to just a dumb pointer. And he starts off as being null. If my new capacity is greater than 0, we make him equal to the new capacity. So we allocate the space for the elements just like we were doing before. But again, we use make unique as opposed to new. And then over here, instead of having to do that delete, I can just say contents equals move temp. Move what's in temp over to contents, deleting whatever contents previously pointed at. So reach for unique pointers, reach for the smart pointers. They're going to save you from memory leaks because they will end up deleting what they point to when you're done using them. Yeah. So you can use smart pointers for the next homework assignment, but it's probably a little bit easier to use the dumb pointers. because again, the smart pointers assert ownership over what they point to. And so things can get a little bit tricky with the deletion because you're like, who owns who? Does like this own the node that comes after it? Or how is that ownership actually asserted? So it's a little bit murky there, so dumb pointers would probably work best for your current assignment. Any other questions about smart pointers? Yeah. So when you create a smart pointer, if you don't set it to something, it will by default be set to null pointer. Unlike a dumb pointer, which if you don't set it to something, it's, I don't know, it's undefined. Any other questions? Okay. So let's talk about the most important thing in all of object-oriented programming, is inheritance and polymorphism. So there are two major relationships in object-oriented programming. There's a has a relationship as an is a relationship. Up till now, we've only really been using has a relationships, right? Like a game of tic-tac-toe had a board. It had players, right? Or if you had a fraction class, it has a numerator. It has a denominator, right? A circle class might have a radians and a circumference, right? They all have these things. Inheritance, though, has to do with a relationship. And if a class is a thing, it should inherit from that. Examples of this that we can't quite cover, like a car is a vehicle, right? A plane is a vehicle, right? A boat is a vehicle. They all do vehicular things, right? They all have like engines, right? And they all are allowed to move from one place to another. But the way that they accomplish these tasks is very different. Or you might say like a circle is a shape, or a square is a shape, right? But the way that you calculate the area of a square versus the area of a circle is very different. But they both have areas. So again, inheritance encapsulates the idea that some things in life are at least something else, but a little bit more or different than the original. If you might want to talk about you and your parents, right? You like inherited some like genetic traits from your parents, right? You maybe got their eyes or their nose or like, I don't know, their, heart defects. I'm not sure, right? The genetic diseases, right? So you inherited some things from both of them, but you're a little bit different. Like you might have different tastes or personalities, or you might both do the same task, but you might wash dishes a little bit differently than your parents wash dishes, right? So we can do the same things when we're writing our code with inheritance. This saves a large rewriting of amount of code for similar objects, because if they're all supposed to do the same thing, you can just reuse the code from your parent class instead of having to rewrite it. It also allows for dynamic behavior, right? Again, all vehicles might have the ability to move from one location to another, but how they do that might be very different. That's the polymorphism part. Any questions about the high-level idea? Okay, let's talk about the syntax. So the way that you say that you inherit from someone is you say class, child class, colon, whatever your access level that you want to inherit from your parent is, then the parent class. This makes the child class inherit from the parent class, or you can say like, the child class inherits from the parent. Pretty much all the protection levels that you're ever going to use are going to be public, and you're never going to do anything else besides that. So just imagine the access level is public, but it can be private or protected. I've seen private before a little bit. That's like, I don't want to allow any more inheritance from this thing. But I've never really seen protected levels of inheritance. Another name for the parent and child classes is the base class and the derived class. So we have our base class, which is the parent class, and from it we derive our child class, which would be the derived class. So as an example, we might have a line, right? And we might also have a line segment, right? And a line is a line segment, except it has endpoints, right? A beginning and an end, right? And I also have a length, which is going to be something that a regular line doesn't, because in a regular line is like infinite, goes on forever in both directions, right? But a line segment and a line, they both have a slope and maybe a y-intercept in terms of how to describe it. So when you inherit from a parent, you pretty much get everything from your parent except for its private members. That class is constructors and destructors. You have to make your own. Its assignment operators, and its friends. Again, we already talked about friendship a little bit, right? You do not get your parents' friends. So if your parent is a friend with Bob, and you're a child from your parent, you are not Bob's. Bob is not your friend as well. You don't have any special privileges to access Bob's stuff. So again, public, protected, and private. Public means you or anyone else can access that thing. Protected means you and your children are able to access that member. Private means only you can access it. So over here we have a class parent, which has a public X, a protected Y, and a private Z. So we have our child class. It can access X because it's public. It can access Y because it's protected, but it cannot access Z because it's private. Does that make sense? So when you inherit from a class at a certain level, the classes all kind of get upgraded to be at least that level when you inherit it. But again, it's very common for there to be anything but public. So if you inherit from a base class at the public level, everything has to be at least as protected as public. So public is at least public, and protected is more restricted than public, right? So it's going to go to protected over here. The private, again, you don't get. If you inherit at a protected level, again, everything has to be at least this protection level. So public gets mapped down to protected, and protected stays at protected, but again, you don't get private. And then when you inherit from the base class at the private level, everything must be at least private when you inherit it. So everything that you inherit from the parent becomes private inside yourself. Questions here? Yeah. So when you do the inheritance, right, you can say, class child colon, notice public is here, so I'm inheriting at the public level. If I said private here, I'd be inheriting with the private level. So that means everything in my parent is going to become private inside myself. Does that make sense? Yeah. Yes, you would inherit protected at the protected level. So basically, like when you inherit back here, you're kind of like upgrading the protection levels to be at least this strict, right, inside yourself. And public is the most relaxed, right? Protected a little bit more strict, and private is the most strict. So when I'm inheriting at the public level, I'm basically saying don't change any of the protection levels because public is the weakest, so everything has to be at least public. So what was public remains public. What was protected, since it's more restricted already, stays at being the protected level, the more restricted level. But if I inherit at the protected level, I say everything that I inherit from my parent must come into me at the protected level. So the public level gets upgraded to protected inside yourself now. And again, the protected still stays at protected. And then if I inherit it at the private level, everything has to be upgraded to at least private level protection inside myself. So both public and protected get upgraded to private inside the class. Any other questions? Again, like you're almost never, ever, ever going to do anything but public when you inherit. Never written any code where I did anything else. If you forget to specify a protection level, what's it default to? Private. Right? If you don't specify a protection level, it gets defaulted to be private. So if you just said something like class child colon parent, it would inherit at the private level. Probably not what you intended. So I have an example of this. Inheritance. So over here I have my base class who has X, Y, and Z at public, protected, and private. And then I had this function over here, print base, which over here in base class, print base just prints out X, Y, and Z. Then I have protected inheritance. Come on, you can do it. Who inherits at a protected level from base class. So X, right, which was originally public in the parent, now gets upgraded to be protected inside this class. Y stays as protected and Z is private. And now when I attempt to print the protected inheritance, I can print X and Y, because again, X was public in my parent, but was now protected when I inherited it. And then Y, again, was protected to begin with, and again, I inherited at a protected level. So I can access both of those things because I'm a child of that class. But Z, I cannot access because Z was private in my parent, right? So I'm not able to access my parent's private members or private methods. Yes? I said at least because when you inherit from the parent, your protection levels must be at least this high, right? Because public is less restrictive, right? So it's not that high, so it needs to be upgraded to be protected. So it's at least that strong. Yeah. And then over here, we have some public inheritance. So I inherit from my class at the public level. X is still public, Y is still protected, Z is private. And again, I can only access X and Y here. X because it's public, Y because it's protected, and Z I can't access because it's private. And if I do private inheritance, X, Y, and Z are now private inside myself. So that means I can access X and Y because they're private to me, but I still can't access Z because that's private to my parents. So we have like some second level inheritance. So over here, second level attempts to inherit publicly from private inheritance. But remember, when private inherited from the base class, right, it upgraded everything to private protection levels. So what variables do you think I'm going to be able to access inside this function? None, right? Because everything is private in my parent. And over here, can't access anything. But because over here in private inheritance, this method was public, I can still call that one, right? Just X, Y, and Z are private, so I can still call that function there. So if we look back here in main, right, I make a base class, a public class, a protected class, and a private class. So I can, print out the different things. I can access the base class as X because it's public, but I can't access Y because it's protected, and Z because it's private, right? I can't access Y here because main, right, is not a child of the base class. In public class, again, I can access X, but not Y and Z because, again, they're both protected and private. In the protected class, I can't access X anymore because when I inherited from the parent, right, I upgraded X to be protected level, and so now I cannot access that member anymore outside that class because it's protected inside the protected class. And inside the private class, everything is private, so I can't access anything inside of it outside that class. Do you guys have any questions here? Yeah.
Last one. Private.
Mm-hmm.
Is there a point to inherit all the whatever's going on inside are private?
So again, like when you inherit from your parent, you don't get the private stuff. So like if you are inheriting from some class and everything in that class would be private, it's like, your parents died and they left you nothing, right? So you don't really get anything. So there wouldn't be much benefit from inheriting from them. The only, there wouldn't be like really any purpose from inheriting from a class where everything was private. You would need some public methods and protected methods for it to make sense. Yeah.
Is there
yes, there is, but it's not called super. You have to specify your parent constructor to run in your constructor. So after the colon, you say parent class name, parentheses, pass it its arguments, and that will initialize the parent portion. then you can do whatever you feel like afterwards. But normally you would initialize your parent parts first, and then you initialize whatever else you need to do differently, or any different things that your parent doesn't have, you would then initialize.
Wait.
It will run the parent's default constructor, the zero argument one, right? But if you want it to run a different one, you have to specify which one to run. Also, if your parent doesn't have a default constructor, a zero argument constructor, then you absolutely have to specify which one to run, right? Because otherwise we don't know how to build the parent part of the child. Because really what happens when you're doing inheritance is you just tack on the child parts to the parent. So if over here is the parent class, and parent inherits from child, right? This is all the parent stuff that's inside of it. When you create a child and you add new stuff, like the new child stuff, and then this whole thing is the child now. The child is the parent plus other stuff. Or you might decide to do some other stuff differently, not add new things. Yeah? Generally, like the only time I've seen any other inheritance besides private is when you inherit from somebody and you don't want anybody to be able to inherit that stuff from you. Right? So you keep it with you. You keep all your parents' parts inside your stuff, and now nobody else can override that if they inherit it from you. Yeah?
So let's say I want to have one parent class, but I don't want to. I don't want to.
Have no choice, right? Because a parent is at least a child, right? The child has the parent parts. You have to initialize the parent parts. Right? If your parent has like A and B members, the A and B members have to be initialized before use. You have to run the parent constructor. Yeah. Yeah, so like if you're an instance of child, right, and you have some member method where you receive another child, you can of course access all of that child's member methods, or access all that child's members. It's public and it's private ones. And so you would also be able to access that child's parent parts that were public and protected, because again, you don't inherit the private parts. So there are generally two reasons to inherit. One is data inheritance. You want all the members of that base class, all the methods as well, but you need to add some more stuff on top of it too to make it be whatever it is that you need to be. The other type is inheritance interface, is that you want the same methods as the base class, but you want to be able to change how they work. They work a little bit different for me as the child. And a lot of times when you inherit for both reasons. I want all the members of my parent, plus I might want to be able to change how some of those things work. So let's say you have that child method and you want to be able to change how that parent method works. When you declare this method in the parent, you need to mark that method as being virtual. Virtual means I give my children the permission to override how this function works. My children can do something in place of what I do, right? Then in the child class, you declare a function with the exact same signature. And this will allow you to give some different behavior than what your parent does. So over here in the parent class, right, I have this virtual void greet, right, where they say hello. But notice void leave. That's goodbye, right? So I cannot change the child's behavior of how leave works, but I can change how greet works because it's marked virtual. So virtual gives your children that permission to override how that method works. This is why all of your destructors needed to be marked virtual, because your children probably need to delete their stuff and then delete your stuff. So again, and then in the child, to be able to modify how these things work, again, we just write a function with the exact same name. One thing that you're probably also going to see is that we add the override keyword at the end of that function. And the override keyword only comes at the end of the declaration. And this is just a check for the compiler to make sure that I really am actually indeed overriding that function, right? That I'm doing what I'm set out to do. If I'm not actually overriding that function, the compiler will throw a complaint at me when it's compiling the code. It's like, oh, hey, you can't really do that. So you should always add that override keyword to the end of your function declarations to mark the fact that you are trying to override the function. This makes it clear for people that read your code and also allows the compiler to check to make sure that what you're doing is correct. So over here with my child, right, I have virtual void greet override. So I'm overriding the greet. So I can see out buenos dias instead. Maybe this child's bilingual, right? Over here in leave, I try to override it, but this is going to cause some problems because this method was not marked virtual in the parent. And so the compiler will give an error. Yes, this will be like in the child header file. So you would include parent, and we're going to see some examples of this in a little bit. And then you would specify which things that you override. You can also totally add new methods like cry down here. It is possible to overload a method. So if I left off this override, I would now have a leave method in the parent and a leave method in the child. But these are two separate leave functions that have no relationship to each other. They just happen to both be named the same thing. This is 100% syntactically legal. Which one gets called, though, is going to be dependent on what you have. If you had an instance of the child, or a pointer to the child, or a reference to the child, then you would call this one that says sayonara. So you would call a child method. If you had a pointer to the parent that pointed to the child, which we'll get to in 1 second, it would actually call the parent's leave, and so they would say goodbye. But again, this is probably what you were not intending to do. So the compiler knows which function to call by checking that object's type. So if it's of type parent, it's going to call the parent method. If it's of type child, it's going to call the child method. So if I do p.greet, since it's a parent, we'll do hello. c.greet, buenos dias, it's, p.leave, goodbye. And then c.leave, goodbye. Again, we're assuming that this function over here is gone. We didn't do it. So we would call our parents method because we don't have one. But we inherited that from them. Any other questions before we keep going? Yeah. Yes, the child can call its parents' methods. So like if in the child's method down here, right, you wanted to say like call your parents a greet, and then you wanted to do your greet of buenos dias, you would say parent : greet. Specify that I want to call my parents greet. And then it would say hello, and then I would go say buenos dias. You can also specify to, if you have an instance of the child, to run one of the parents' methods by doing, so if back here we did c.parent : greet, then it would run the parent's greet as opposed to the child's. Because we said we're very specific about which one we wanted to have happen. Again, this is what we just talked about. Right, parent : greet. So display hello, and then we'll do our things. This was about calling the constructor. So again, every constructor still needs a class. In the child class, you still need to initialize the parent part of yourself. If you choose not to, again, the 0 argument constructor is going to be called. If you want to initialize the parent portion using some other constructor, call that in the initializer list. So if over here I had parent that took, an x and a y and then initialized those member variables, and then did something else. Over here in the child part, notice he also gets an x, a y, a z, and an a. So I call my parent with x and y to go initialize those portions of myself by using this constructor, and then I set my z to z and my a to be a plus 12 for whatever reason. Then I go run whatever additional code that I need to have happen. Yeah. No, so again, parent is just a stand-in right now for the name of the class. Parent is not a keyword at all, right? So like if you wanted to call like your grandfather's constructor, you'd have to say whatever that class's name is, colon, class's name, parenthesis, arguments. But generally, like when you would call your parent, right? Your parent would call the grandfather. So that would be taken care of for you. So you generally wouldn't have to worry about getting that high up the level. But if you did, their class name, colon, method will run that one. I guess we need to go, so we will wrap this up tonight. We'll get into some examples of it. We might add some AIs to our tic-tac-toe code, and so that we can have different types of players. A human player, like we already have, and a AI player, so that we can choose between which ones we want to have play.
So for the tic-tac-toe, let's say I want my player to have move as a child.
So now you're getting into a has a relationship instead of is a relationship.
Right.
Is a player a move?
Sorry?
Is a player a move?
No.
But a player has a move.
Yes.
So that would be one of your members, not inheritance.
Would be a member, meaning
It would be like
a player would create an instance of a move?
so like back here, right? Notice that over here in vector, right? Contents, num elements, and cur size are all members of the class, right? A vector has contents. A vector has a number of elements. A vector has a current size, right? So if this class was of type player, right, and you wanted to move, right, you'd be like
a reference to a move.
You'd be like, I have a move M, right? So the question that you want to ask here is like, does a player have a move? Is a player made up of a move, or does a player so? Two questions. There's the has a is a question, right?
Yeah.
Has a or is a determines whether you have a instance of that class inside of yourself as a member, like we do here. And then the is a relationship, right, is whether you inherit. For example, right, a string is a vector of characters, right? So that would imply inheritance, right? I want to inherit from a vector of characters.
Okay. So the reason I'm asking is because...
But yeah, one thing. But like with the move, though, right, you have to ask yourself, does a player have a move?
Yeah.
Or does a player make a move?
Yes. So I was trying for inheritance because I was thinking that in your code you had like move, that make move, and you were passing the board.
Yes.
I thought, oh, what if like move was a child of the board, and then I would do board that make move, and the board would know about the move. That doesn't make sense.
But like, is a move a board?
No.
No. So you would not want to use inheritance.
Right. So that's
there.
fundamentally flawed.
Yes.
But is that just in C++ or in any OOP?
In any object-oriented language, if you cannot say this is a something of that, you do not want to be using inheritance. Like something that might get a little bit more confusing is, have you ever played Pokemon?
No.
No? Well, in Pokemon, right, there are different Pokemon. They have types. Like there might be a fire type or an ice type, right, or a water type. Now you're going to have to ask yourself the question, right, does a Pokemon have a type? Or is this Pokemon a ice type Pokemon, right? Like Charmander is a fire type Pokemon. Or do you want to rearrange it where Charmander has a type which is fire? So sometimes the way the statements can be a little ambiguous.
I've been using that for a long time. Okay, thank you.
Yeah.
First one is about
yes.
So I'm wondering, you gave out the .h file for the template configuration of double link. Like we add the code on top of the code assignment.
Like because like it should have been like just declarations, correct?
Yeah.
Right. So generally, like we have here with the vector. Notice I have like I would have given you something like this. Like here's template type name t vector, right? It has all this stuff that you need to implement, right? And then down here we have the curly bracket. Notice all the definitions come afterwards.
Because we have to implement both and configurator. In that case, at the set of the file, where
Well, you have to put the yes, they end up being in the header file, right? Because the code is templated. Remember, all templated code goes into the header files, not to the CPP. Because the compiler needs all the information at once to be able to generate that class, right? So if it only had like, okay, the class has these members, but doesn't know like what code to write to instantiate it, then it's gonna fail.
also because way of making the class creator constant of like base class as.
So yeah, I totally know what you're getting with, and I always want to do that. The problem though has to do with some of the typing. Let me stop this because I forgot.